Hello everyone. So today we will be going through a Q&A recap. So we will be having question and answers, short question and answers for IPv6 and a few special addresses 0000 and 255.255.255.255. So let's get started. So we will be covering uh, short question and answers on following topics of IPv6, IPv4 address of 0.0.0.0.0, and IPv4 address of 255.255.255.255. So essentially, we have covered these basic topics in computer networking in previous videos in our computer network series. But today is just a recap so that we can recall what we have learned so far. Okay. So jumping on to the question and answers on those uh, topics. So the first one is, let me just open this one. Okay. So the first one is, why was IPv6 created? So in a short, IPv4 only supports 4.3 billion addresses, and which is based on our IPv4 address range. So as we know that IPv4 addresses uh, are 32 bits addresses. So it means that the maximum IP addresses or the maximum IP addresses we can have is 2 to the power 32. So this 4.3 billion addresses is just corresponding to the output of 2 to the power 32, which we do not need to remember. But in a sense, if somebody asks why IPv6 uh, is created, so it's just that IPv4 is 32-bit address, and corresponding to 32-bit, we can have maximum 2 to the power 32 IPv4 addresses, which is not sufficient enough uh, for devices if we have more than 40 plus billion devices connected to the internet. So, and just one more thing, IPv4 is Internet Protocol version 4 and IPv6 is Internet Protocol version 6. Okay. So then the next one is, what format does IPv6 use? So now, because IPv6 is actually created to uh, basically support a long range, as we know that for IPv4, it's just to keep our 32 addresses. But now, because IPv6 is uh, having a bigger range, so it means that to represent IPv6 addresses, we are making use of additional characters. So basically, IPv6 addresses, every time you see, so they will be represented using hexadecimal characters. So hexadecimal is a base 16 number system, and we know that if it is base 16, then it means like 0 to 15 different characters we can have. So now we know that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But after 9, what we have is A, B, C, D, E, F. Okay. So it means we have the hexadecimal characters in IPv6 addressing. Okay. And these hexadecimal characters or groups are separated by colons. So in relation to the same thing, like how many groups does an IPv6 address have? So IPv6 addresses are 8 groups of 4 hexadecimal characters, wherein each group is separated by a colon. So if you look at this example, it is 2001 colon 0D B8 colon 85A3, and then finally we have 7334 at the end. So it has 8 different groups of hexadecimal characters, and each group is separated by colon. Then in relation to how many bits is an IPv6 address? So it is 128 bits. So as we have just learned that IPv6 was initially created to support a large number of devices connected to the internet. As in IPv4, it is 32-bit address. So to bridge that gap, IPv6 has 128 bits. So how many bytes is an IPv6 address? So just like we know 8 bits is 1 byte. So if we divide 128 by 8, so it will come to 16. So it's 16 bytes or 128 bits. Then how many unique IPv6 addresses are possible? So we do not need to remember the exact number, but just as we noted earlier that IPv4 address is 32 bits and we know it is 2 to the power 32 bits. So based on the same analogy, IPv6 is 128 bits. So maximum addresses or unique addresses possible are 2 to the power 128. And why we are using 2 to the power? Because at each bit, either it can be 0 or it can be 1. So there are only 2 bits, right? 0 or 1. So that's why, and then the total number of positions we have is 128. So that's why it's 2 to the power 128 unique IPv6 addresses we can have. Then sometimes if you run the ipconfig command, which we know we learned previously that ipconfig command is used to find the IP address. So now if we are being allocated or a device is being allocated IPv6 address, so sometimes you might encounter that IPv6 address is having a colon and colon, 2 times colon. So basically it's just like sometimes you will see in this example uh, that maybe let's talk about the next question first, and then we will be able to correlate what does this colon colon mean in an IPv6 address. So in this we have, the question is, what is the IPv6 loopback address? So we haven't covered loopback addresses so far for both IPv4 and IPv6, but just for example purpose, uh, loopback address is the address of the device itself. So in case of IPv4, it is 127.0.0.1. So basically, loopback address, though we will cover later in the videos, but it's just like if we send any message to this IP address of 127.0.0.1, then it will not go outside. Okay, it's just the loopback address. So it's just the address of the machine itself from where we are sending the message. Okay. So equivalent to this I 127.0.0.1 loopback address in IPv4, we have colon colon 1 as the loopback address represented for IPv6. And it's just a shorthand notation. It's not the only way to write it. As you can see here, and we just learned previously that IPv6 addresses are like 8 groups separated by colon. So in case of loopback address, it will be like it is represented as like this. So 7 groups has 0, 0, 0, 0. Okay, and then the last group has 0, 0, 0, 1. So now as per the rules, some of the rules, we can shorten this. So how we can shorten this is we can remove the leading zeros from each group. So if we remove the leading zeros from each group where we have 8 groups, then our loopback address in IPv6 will be 0:0:0, and at the end it will be :1. So like for the 7 groups, we just have single zero, and for the last group, we just have 1. So we removed the leading zeros from each group. So we can also write it like this. And then as well, there is another rule to shorten it wherein we can replace all the consecutive zero groups with just colon and colon. So if we, so basically we have the 7 groups. If we remove the leading zeros, so now because these 7 groups are consecutive zeros, so we can all we can replace it with just colon and colon. So colon and colon and then 1. So essentially all these syntaxes are valid, but ::1 is universally accepted in the standard way to write the loopback address for IPv6. Okay. So now if you ever encounter IPv6 address like ::1, then it's a loopback address for the device. So now moving on to the previous question. So if somebody asks what does : mean in an IPv6 address? So it's just a shorthand notation because we have replaced one or more consecutive groups of all zeros to shorten the address. And then one more important rule is it can only be used once. Okay. So now somebody might ask, why is : ::1 the standard way? So maybe because it is the shortest possible form, and then instantly it can be recognizable to all network engineers. So for example, if we write a very full notation to represent a loopback address for IPv6, wherein we have 7 groups of 0000, and then the last group as 0001, then somebody has to carefully write all the zeros to make sure that it is like each group has 4 zeros except the last one, and as well as whoever is looking at the IP v6 loopback address, then the full one, then he or she just have to put more effort to see if whether it is written correctly or not. So I think in that perspective, it is just better to write it : ::1. So that's why we are saying instantly recognizable to all network engineers, used in all the documentation, RFCs, and operating systems. And you might also see the same notation, shorthand notation of : ::1 in ipconfig /all command output. So that is why it is the standard and universally accepted way to write the loopback address like this. Then the next one is, what is dual stack? So sometimes you might encounter a term being used at a dual stack. So when a device runs both IPv4 and IPv6 simultaneously, which most modern devices do this today, so it means dual stack. Dual means two stack. We have IPv4 as well as IPv6. Maybe we can cover in later videos how dual stack works and things like that. But for now, just remember, wherever you see dual stack being used in computer networking, it just means that the device supports both IPv4 and IPv6 simultaneously. What is NAT? Network Address Translation. So we haven't covered it yet, but it's just like it allows multiple devices to share a single public IP address. So I think we will cover it later in next videos. But for now, network address translation is just uh, allows multiple devices to share a single public IP address. Then the next one is, what does 0.0.0.0 meaning? Okay, so it has multiple meanings. Most commonly, it means no IP address assigned yet during the DHCP process, or it could be something else in a different context, like all network interfaces when used by server applications. Then can you assign 0.0.0.0 to your device manually? Some systems allow it, but we should never do that because it will completely isolate our device from the network. So we will not be having any internet or local network communication, complete isolation the device will be in. So you may go through the previous videos about when we talked about when very first time a laptop or device boots up, and it basically uh, sends a request, shouts over the local network to get an IP address via the DHCP client service mechanism on the device. So that time, it because it initially doesn't have an IP address, so it just sends the message that I do not have an IP address yet. Is there a DHCP server and things like that? So during that conversation to get an dynamic IP address, it initially puts its IP address to 0.0.0.0, so which means that it doesn't have an IP address yet. So it depends like in which context we are talking about this 0.0.0.0 meaning. So in this IP address allocation, it means no IP address assigned yet. But in some other context, server might use this IP address to say, I am accepting traffic from all the network interfaces. Okay. So now, what is 255.255.255.255? Again, we had gone through it earlier when we understood how the IP address is allocated to a device during when the laptop is booting up first time via the DHCP client service uh, communication and shout to the over the network to get an IP address from the router. But then to basically shout over the network, it has to use the broadcast address. So this 255.255.255.255 is called limited broadcast address because it is a mechanism to send a message to all the devices on the local network simultaneously. Okay. And then one question might come to our mind that when a device is sending a message via this broadcast address, then is it that this message goes to the internet as well? So the answer is no. Router never forwards broadcast traffic to the internet. It stays within the local network only. And then we have few final questions as well. Can you assign 255.255.255.255 to your device? So the answer is no, because it is a broadcast address and it's not a valid device address. And then what is the main difference between 0.0.0.0 and 255.255.255.255? So 0.0.0.0 means no address or all addresses depending on the context. And then 255, 255, 255, 255 means sent to all devices on local network. It is the broadcast address. So that's what we had crafted few question and answers on IPv6 and IPv4 special addresses in this video, which should be useful to recall and think about like what we had discussed previously. But here is the reference material wherein we have the link for each topic we have gone through so far on IPv4 MAC addresses, reserved IPv4 addresses, how does IP allocation works, DHCP explained, and things like that. So also we have the link here for our YouTube channel, which is CS Back to Basics. So if you search for this channel in YouTube, then you will be able to see the complete playlist for computer networking series. So I look forward to create detailed videos on different topics, which should cover all the practical aspects of computer networking. So keep watching. Thank you and happy learning. Thank you.